Hello everyone, this is Dr. ElSafty. Welcome to the course of matrix structure analysis that has prerequisite of analysis of structures. I hope that you guys are having a good time and we are going to enjoy this class. So let's get started, and we're going to have some handouts and some videos that I'm going to share with you. Basically, to give you an idea about this course, why do we even study this material or this course methods? Basically, if you'd like to analyze any structure, we were able to do that if the structure is statically determined structure, meaning the number of unknowns equal to the number of equations. However, when you have something like this frame right here that you can see right here, it is statically indeterminate structure, and we would like to find out not just the reactions but also the deformations. And also, if you have a truss that has so many elements, as you can see right here, you can use this method, using the computer method, to be able to find out the reactions and displacements as well. You can use also hand calculations. We're going to discuss that. In some other structures that might be complicated, you can analyze these structures. If you have this kind of space trusses, you can analyze that. So basically, this course gives you the tool, which is very simple. It's a software that you're going to be using in order for you to be able to analyze complex structures. So we are going to explain the basic fundamentals of using the method, which what we call the stiffness method, for analyzing the structures. We're going to start with few lectures talking about truss, that's number 1, beam, that's number 2, frame, that's number 3, and it's going to be a little bit of a tedious procedure to come up with these calculations. After we finish those in the first couple weeks or 3 weeks, then you're going to be starting working on your computer software, and I'm going to give you the instructions of how to download that and use it and submit your homework assignments or tests, as we're going to discuss. So let's get started here. That method is a traditional method for analysis of trusses, frames, and beams. And basically, we're going to have the theory of the structure analysis in order for us to determine the reactions and determine the deformations as well, not just for statically determined structures, but also for statically indeterminate structures, which is fantastic. In every firm that you're going to be working at, and you're going to be using software for you to analyze the structure, it's going to be a very nice way for you to analyze the structure in a very short period of time. We're going to be talking about something called stiffness matrix versus flexibility matrix, and we are going to be discussing that. So the topics covered are listed here: flexibility versus stiffness, and that we are going to be working on stiffness method. Basically, that's basically our main objective. And then we are going to be talking about beams, trusses, and frames, and we are going to be talking about something called the coordinate transformation, and we will go to the truss analysis, and we are going to go to the beam analysis and frame analysis. And I just want to highlight something here, that I'm going to explain the theory. I'll teach you the theory, how to come up with this matrix, and I will give you a tutorial for the software, but I'm not going to go through the details of the software. It's your responsibility as a student to navigate through that, and you are going to be way much better than any of us as faculty. You guys are young, and you are going to get the hang of that software very easily, and we can discuss analysis afterwards. The beauty of this course, it's an introduction to something called finite element method. So whenever you work in a structure firm, you're going to be dealing with these finite element methods, and that will help you analyze structures as simple as possible. The course objective is to prepare the students like you guys for a structure engineering community and for grad school if you're going to be specialized in this method. or structures. And basically, even if you're on water resources, you will be using finite element as well, by the way. So the finite element is not just pertaining to structural engineering, but it's also for other aspects like geotechnical engineering and water resources and hydraulics. So you will like to be familiar with that software, and please spend as much time as possible familiarizing yourself with that, and you'll find tons of videos online to navigate through that software. And straightforward, but just practice with very simple problems. And once you finish these simple problems, you can move to the complex structures afterwards. That's not a problem. The format of this course, as you notice, is like an online course. It's not face-to-face, and you're going to have your own computer. You download your software on it, and you will be able to do the assignments. So let's see what is the tentative schedule that we're going to have here. We're going to have an introduction, and we're going to have stiffness method. What is that method is like? More importantly, these are the three things that I want you to focus on: truss, beams, and frames. This is the task, and for each one of them, you're going to have a project, like an assignment, very simple assignment, that you will calculate that using hand calculation. You're going to analyze that using hand calculation and using the software at the end. So these are the three main projects that we're going to have, and then we're going to have either a final exam or a final project. So it's a very, very straightforward class. It shouldn't be a problem at all, and I assure you, you guys are going to be working very well throughout this class, and you're going to submit these assignments. And if I modify anything by adding more assignments, I will update you. This is 75% of the grade is going to be on this assignments, and then 25% for your final grade. So I hope that helps you guys understand exactly what we're looking for and the expectations for this course. And again, this is a nice course that you will be able to analyze truss like that without doing any calculations. You're going to enter something called the nodes and the elements. We're going to discuss that, and then you get output. It's illustrating the displacements and forces developed in these members. Very nice software that you're going to have, but pay attention to something. As we always know, that the output will be flashy and nice and colorful, and you think it's correct. You have to verify that against hand calculations in order for you to be confident with whatever you're getting, because you're going to sign and seal at the end of the day. Softwares can be misleading. They give you very nice outcome, but as you know, garbage in, garbage out. If you have input that is incorrect, it will give you output that is very nice and printed, and you need to know whether this output is correct or not. So that is what we're going to be doing, developing this kind of sense of engineering to judge your input and to judge the output that you're getting, so that you can be confident in submitting these calculations to the honor. So I hope you guys are enjoying your time now, and I'm gonna get started. And it seems that we're gonna have like a lecture or two every week, and I'll give you plenty of time in order for you to accomplish the tasks that we're having. When I say project for truss, it might be several trusses, like several mini projects, like several assignments that you can do, and each one of them is not going to take more than an hour just to finish and on your computer. All right, guys, so we're going to start in the next lecture or next session talking about the stiffness method, and why do we even need that stiffness method. How can we analyze the structure, and how can we break the structure into small pieces? We call it discrete elements. And then how can we develop something called a matrix for the element, and then matrix for the whole entire structure? How can we solve this? So again, there are two parts for this course. One of them is hand calculations. It might be very tedious in the first few weeks. That's understood. And I'm going to provide you with all the information that you need. And then the most important part afterwards is software, which is something that you're going to enjoy using. All right, you guys have a wonderful day, and we will talk to you very shortly.